Today I will discuss on some numerical problem on mean precipitation. I have already discussed and described the various method of mean rainfall calculation in my previous video, that is video number 3. So you all are requested to go through my previous video. Okay, let us go through now the first example. I have taken my first example from arithmetic mean average method. In this question, it is asked that using arithmetic average method, find the average rainfall over a catchment. The rain gauge data is 12.6, 18.8, 14.8, 10.4 and 16.2 mm. Very easy. In my previous video, I also given an example of arithmetic mean method. In the formula, we have to find the arithmetic mean method. That means simply mean method. The formula was that the summation of all the given data, that is the precipitation, divided by the total number of data or precipitation. Here the total number of rainfall is given 5 numbers: 12.6, 18.8, 14.8, 10.4 and 16.2. Therefore, summation of the all given data will be P1 plus P2 plus P3 up to P5. That means 12.6 plus 18.8 plus 14.8 plus 10.4 plus 16.2, and total number of precipitation or data is 5. Therefore, n equal to 5, n for number of data, so divided by 5. My answer is came 14.56 mm. Therefore, mean precipitation is 14.56. Very easy. So let us go through my second example. I have taken my second example from the THEISSON POLYGON method, which is the second method for calculating the mean rainfall. In the question, it is asked that using THEISSON POLYGON method, find the average rainfall over a catchment. The data is, first data is rain gauge station. That means the name of the rain gauge station is A, B, C, D, E. That means here total 5 number of rain gauge station is given in the question, and the corresponding polygon area is given in square kilometer. That means 40 corresponding station A, 45 square kilometer, 35, 30 and 43, and corresponding precipitation in millimeter unit are also given. First one is 30.8, then 33.4, 34.6, 32.6 and 24.6. So I have solved this problem in the tabulation form given here. In table, I used total 4 number of column. In first column, I have written the name of the rain gauge station, which are given in the question simply A, B, C, D, E. And in the second column, I have written the polygonal area or polygon area in square kilometer, which are also given in the question. The area is 40 square kilometer corresponding station A, 45 corresponding station B, 38 corresponding station C, 30 corresponding station D and 43 square kilometer corresponding station E. Next, in the third column, I have written the value of the precipitation in mm, which are also given in the question: 30.8, 33.4, 34.6, 32.6 and 24.6. And in the last column, column number 4th, I have calculated the product of polygonal area and precipitation. We know that in the THEISSON polygon method, we have find the influence area of corresponding station. What? The influence area of the corresponding station in the form of polygon. Generally, we have to find the polygonal area by joining the all station and forming the triangle. Then we have to draw the perpendicular bisector to form polygon, and the corresponding polygonal area is the influence area of the corresponding Rengauss station. But in this question, polygonal area also given. That means the corresponding station and that corresponding station polygon area is given. So we have not find to the polygonal area. It is very easy example, and this type of example is frequently asked in our semester examination. So in column number 4, I have just multiplied the precipitation value to the corresponding polygonal area. That means AI into PI. That means A1, P1, A2 into P2, A3 into P3, A4 into P4 up to A5 into P5 I have calculated. So the total summation value of AI into PI, that means summation of AI into PI, that is A1 plus P1 plus P2, sorry, A1 plus P1 plus A2 P2 plus A3 P3 plus A4 P4 plus A5 P5 is become 6085.6. So as per our formula is that our formula is summation of AI into PI divided by summation of A, that means total area. So therefore summation of AI into PI is 6085.6, and the total area means total area of the basin or polygon, that is 193. So that is summation of AI PI divided by summation of AI is become 31.53 mm. So in this case our mean rainfall or mean precipitation by average precipitation is 31.53 mm. Next, my third example is based on also the THEISSON polygon method. In this question, it is asked that estimate the total volume of rainfall water received in meter cube. Note that we have to find the total volume of rainfall in meter cube, not rainfall depth, rainfall volume. Very easy. Rainfall volume is nothing but the rainfall depth into area of the basin. So first we have to find the rainfall depth, that means average rainfall depth. Then we will multiply the area and we will get the rainfall volume. Okay, over a basin of 4444 ha means hectare, for it is the area of the basin, for the following observation. Station A, B, C, D, E. Here total phone number of station is given and the name of the station is A, B, C, D, E. Sometime in the many question the name of the station or the designation of station is also given in the form of 1, 2, 3, 4. Okay, and second one is there polygonal area, same as previous problem. Polygon area are also given in ha, that means in hectare unit, and observed rainfall also given in mm. If you calculate the total area is given in the table form 518777906, you also get the this value 4444. Okay, you can check it. So now let us solve the problem. Same as the previous problem, I have solved this problem here not using tabular form. previous problem I used tabular form. Here I just calculated. That means summation of the PIAI and divided by total area. So here also polygonal area and rainfall is given. So I have used simply P1 A1 plus P2 A2. Here I have used the notation A B C D E instead of 1 2 3 4 5 because here the name of the stations are given in the form of A B C D E. Okay, so I have calculate all the value area corresponding the rainfall divided by the total polygonal area. Okay, and my answer became 146.67, that means 146.67 mm. Very easy example, same as previous and frequently asked also this type of question, but 146.67 is my average rainfall depth, but in my question it is asked to find the rainfall volume in meter cube. এবার what is the rainfall volume? The rainfall volume is nothing but the rainfall depth into basin area. So now I will find the rainfall volume. So therefore the rainfall volume over the basin is, this is the area of basin into mean rainfall, into mean rainfall. Even now the area of the basin is given 444 ha. Ha means hectare. So we have to convert it into meter square because we have to find the answer in meter cube. So note that 1 ha means 1 hectare equal to 10 to the power 4 meter square. It is very important. Note down. 1 hectare equal to 10 to the power 4 meter square. So it is 10 to the power 4 into mean rainfall, that means 146.67 mm. So here we have also to convert the mm into meter. So divided by 1000, we know that 1 meter equal to 1000 mm. My answer is 6.52 into 10 to the power 6 meter cube. Okay, so now my last example is based on ISOHYTAL method. This is the third method to find out the mean rainfall. In my previous video there also I have given an example of ISOHYTAL method, and here I am also given another example which is slightly different from the last example. Here it is asked that the following table gives the data of an ISOHYTAL map. The total area of the basin is 300 square kilometer. Compute the average depth of rainfall over the basin. The isohet in centimeter unit is given and the basin area covered by the isohet in square kilometer is given. See that here the total basin area is given in 300 square kilometer, and in the table it is given that for 35 isohet is area is 17, next 45, 75, 165, 215 and 300. This area is given is not an individual area covered by the isohet, because if we add or sum the total area then we will get the total area obviously more than 300 square kilometer, but in my question it is given that total area is 300 square kilometer. So in this table the corresponding isoHYTAL area, isoHYTAL, the area is given cumulative area, not individual area. Cumulative area means the area corresponding isohet is nothing but the summation of the previous area. That means the area corresponding the isohet plus the area of the previous station or previous isohet. Okay, let's solve it. Before solve, I have drawn a basin, this one, like this, and the isohet is like this. First one is 40, 35, 30, 25, 20, 15 and 10. And that area is given in the form that corresponding 40 centimeter isohet, no area is given. Next 35, the area is given 17. That means after 40 up to 35, the area is 17. That means this is 40, this is 35 and area is covered 70. Therefore the area between 40 and 35 is 17. That means this area. Sorry, this area means total area is not covered in the basin. This will be this only, because this portion is outside the basin. Only this portion is including in the basin. Next, after 35 up to 30, area is 45. That means up to 30, area is 45. This means this is 30 and area is 45. That means from here to here up to 30, area is 45, because this area is cumulative area. That means corresponding area plus previous area. Next, after 30 up to 25, area is 75. That means up to 25, from starting of the basin up to 25, total area is 75. Okay, so up to 10, total area is 300. That means total 300 area is covered. Okay, so I have solved it in the tabular form. In table there are total 5 number of column. In first column I have written the value of isohet in centimeter, which are given in my question, 40, 35, 30 up to 10. In the second column I have written the basin area covered by the isohet, which are given also in my question, 17, 14, 5 up to 300. And in the third column I have calculated the value of incremental area. That means net incremental area between the two isohet. 40 corresponding no area. That means 40 is the starting isohet. After 40 there is 35. So therefore the net incremental area of the net incremental area between the isohet 40 and 35 is 17. Next, the incremental area will be 28 between 35 and 30. How it is come? 20 is nothing but the 45 minus 17, because 45 is the corresponding value plus previous value. Okay, so the net incremental area will be 45 minus previous value. That means 45 minus 17, 28. Same as the area between 30 and 25 will be 75 minus 45. That means 30. Same as the area between 25 and 20 will be 165 minus 75. It will be 90. Same, the area between 20 and 15 will be 215 minus 165. That means 50. Next, the area between the 15 and 10 will be 300 minus 215. That means 85. And the total area will be 300, which is also given in the question. Let's check it. Use calculator and sum all the net incremental area. It will become 300. Okay. If it not become 300, then that means calculation is wrong. Okay. Next, in the fourth column, I have just find the average rainfall on the incremental area. So, what will be the average rainfall? Corresponding area 17, it will be the average between this 40 and 35. It becomes 37.5. That means 40 plus 35 divided by 2, 37.5. Next, what will be the average rainfall? Corresponding 28, it will be the average of these two, 35 plus 30, 32.5. Okay. Same, what will be the average rainfall corresponding to the area 30? It will be average of 30 and 25. It will become 27.5. Okay. And so on. In the last column, I have find just rainfall volume, that is Pi into Ai, precipitation or rainfall into corresponding area. That means net incremental area and corresponding mean rainfall. (17 into 37.5, 28 into 32.5, it will become 910, 30 into 27.5, it become 825, up ... 85 into 12.5, it will become 1062.5. So, the summation of all this, summation of P into A will become 6335. So, as per our formula, mean rainfall will be summation of Pi into Ai divided by total basin area. That means 6335 divided by 300. It will become 21.116 centimeter. That means mean rainfall is 21.116 centimeter. It is a very important example, frequently asked in our examination. Okay, thank you.